Hello everyone, today I would love to take you through Introduction to Organic Chemistry, and this majorly will deal with the students who are pursuing a pharmacy program where they are required to do different what we call branches of chemistry, where we have the organic, inorganic type of chemistry as well as the analytical bit of chemistry. So the study objectives of this lecture today, we are going to look at Introduction to Organic Chemistry. We shall look at what are the properties of carbon, and then what is catenation. Then we shall look at bonding. We shall also look at orbitals. We shall look at what functional groups are and their examples. We shall look at homologous series and examples. Define IUPAC nomenclature, isomerism in organic compounds, organic reactions, and then we shall deal with hydrocarbons. And then lastly, part of the hydrocarbons where we have the alkanes. So let us start with Introduction to Organic Chemistry. Organic chemistry is the study of chemical compounds that contain carbon other than simple salts like carbonates, oxides, and carbates. So all those other chemical compounds that have carbon atom in them other than salts of carbonates. Of course, we know that a carbonate has carbon and oxygen, oxides that has oxygen component in it, and as well as carbide has carbon, and then other elements of the periodic table. Or we can also define it as the scientific study of the structure, properties, composition, reactions, and synthesis of chemical compounds that contain carbon. So let's look at the properties of carbon after we have known what organic chemistry is. We know that we are going to base on studying carbon and its compounds, apart from the carbonates and then carbides and oxides. So as we look at the different compounds of carbon, we need to know what are the properties of carbon as an atom of the periodic table, not as an element of the periodic table. Sorry about that. Carbon is a chemical element with a symbol C and atomic number 6. That's the first property you can talk about. So carbon contains 6 protons in its nucleus. It is non-metallic and then tetravalent, making 4 electrons available to form a covalent chemical bond. Carbon undergoes catenation, thus ability to form multiple stable covalent bonds. Carbon has the highest sublimation point. Carbon occurs in different allotropes that exhibit different physical and chemical properties. We know allotrope is the existence of an element of the periodic table in 2 or more forms. When an element is able to exist or appear or be not represented, but existing in 2 or more different forms. So we are going to see that carbon also has different allotropes because it has ability to exist in 2 or more forms. So those are basically our properties of carbon. We have highest sublimation point, allotropy, it exists in allotropy, undergoes catenation, and we are going to look at what catenation is and how this carbon as an element of the periodic table undergoes catenation. Tetravalent, making 4 electrons available to form a covalent chemical bond, and then the non-metallic property. So allotropes of carbon. Allotrope is the existence of a chemical element in 2 or more forms, which may differ in the arrangement of atoms in a crystalline solid. Allotropes, like how I was saying what allotropy is, existence of a chemical element in 2 or more forms, which may differ in the arrangement of atoms in a crystalline solid. Allotropes are different structural forms of the same element that can exhibit quite different physical properties and chemical properties. So we have 3 allotropes of carbon. We have diamond, graphite, and amorphous. So let us see the different properties physical properties of these two allotropes of carbon, where we have graphite and diamond. Graphite is hexagonal shape, has a hexagonal shape. A hexagon is a six-sided polygon. So having a hexagonal shape, meaning it has 6 sides. Graphite has 6 sides. And then diamond, most of us have seen the structure of diamond, or we can compare it to the kite. There are people us who fly kites in different occasions and seasons. So we can also say that diamond has a tetrahedral shape. Like I can compare it to the size or the shape of a kite. Yeah, so that is tetrahedral shape, having 4 sides. That is how diamond looks like. And then we see that as when graphite is opaque and black, diamond is transparent. So you look at what do you want to differentiate the two from? Is it the shape? Is it the color? Is it the softness? Is it on electricity? How they conduct electricity? Is it on thermal conduction, heat, conduction of heat? And then is it a lubricant? That is the major outputs you can have. And then you need to know how does graphite differ from diamond, if it is shape, if it is the color or appearance. You also need to know how to differentiate. We say opaque and black, and then highly transparent, conduct electricity, naturally soft, naturally hard, conduct electricity, electrical insulator. And then we see graphite is a thermal insulator, as well as the other one is the highest thermal conductor. A thermal insulator cannot conduct heat, cannot produce heat, something like that. And then a good lubricant, ultimate abrasive. So after knowing this, what we need to know about amorphous, it has no shape, it is shapeless, and then we can say it is color black also and opaque. However, we're not sure whether it is very hard, and then does not conduct electricity. It is a dormant allotrope of carbon. So since it is dormant, has no shape, and then majorly black, we give an example of charcoal. For countries that use charcoal to produce fuel for cooking or to enable the cooking process. So we find that charcoal is a substance that we can relate to amorphous, that we can commonly call amorphous structure. So after looking at this specific property of carbon, we want to look at another property of carbon, and that takes us to catenation. Catenation is another property of carbon. So catenation is the bonding of atoms of the same element in a series called a chain. Is the bonding of atoms of the same element in the series called a chain. Catenation occurs most readily with carbon, which forms covalent bonds with other carbon atoms to form a long chain or a ring. So we find that carbon is unique in a way that it can bond, it can form a covalent bond. We know that when we look at bonding, we have different types of bonds, where we have the covalent bond, ionic bond, dative bond, and metallic bond. We also have hydrogen bonds. So when you look at your chemistry, you find that there are a number of types of bonds. However, when we look at carbon, we said it is a nonmetal, and nonmetals have a behavior of bonding to each other in order to become stable. Atoms, elements in the periodic table have a tendency of bonding to each other in order to attain a stable structure, in order to become stable. Because when we look at carbon having an atomic number of 6, and then when we look at the electronic configuration, we see that our carbon will lack some number of electrons to become stable. So it has to share with another carbon atom so that it can become stable. So when we look at carbon, we say that carbon can bond to itself to form a ring. It can bond to itself to form a chain. So when it bonds to itself to form a chain, it can either have branches on the chain, or the chain can be a long chain, like a long chain without branches. So it can either have branch or can be without, open without any branch. We are going to deal more on that. However, when we look at this bonding, carbon can bond to itself using a single bond, or it can have a single bond to itself, to carbon, or it can also have carbon to carbon double bond, and we can also have it bonding to each other using a triple bond. We are going to focus more on that, but we needed to understand what catenation is, and what we needed to put in mind is briefly what I have just spoken about. There are two types of chains, which include open-ended chain and then cyclic chain, which is a closed. Like open-ended, like I said, this is an example of an open-ended chain. We find that carbon has a valency of 4, and since it has a valency of 4, meaning it needs to have 4 bonds. So this is the first bond and the 3, so this becomes 4. So when you look at for this carbon atom, this is one bond bonding to this is another, so those are already 2. How many left? 2. So that is why we have this structure written like this: CH3, CH2, 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 and then CH3. Examples of a cyclic chain, we see an example here. Right, so we see this as benzene giving us an example of a cyclic chain. So we find that this is enclosed. This is taken to have a carbon atom on it, and then all these corners we see. So this is an example of a hexagon, where we say that graphite is hexagonal. So we expect graphite to have this shape, but I'm not saying that this specific structure is graphite. However, this one is benzene. Benzene, we are going to focus more on it. We shall go in depth on it and then discuss more about what it is all about. But however, this is how a cyclic chain looks like. Because we say that it can bond to itself using either open chain or a cyclic chain. So we see that all the different corners, all the different edges, depending on how you'd call this, can be edge, can be a corner, something like that. So we find that this is an enclosed chain. So that is what catenation is, and carbon has that property, that unique property of having or undergoing catenation. That takes us to another slide, and in this specific slide I am going to take you through bonding. Okay, so sorry about that. So let's look at bonding. So we see that bonding is the lasting attraction between atoms, ions, or molecules that enable the formation of a chemical compound. The lasting attraction, we find that different atoms, ions, molecules, elements bond to form a chemical compound. A compound is a combination, or it has atoms, ions, molecules in it. So that is what bonding is, lasting attraction. This attraction can be either ionic, covalent, dative, metallic. That is the attraction. We see that metallic is different and it has its characteristics. Ionic is different and it has its characteristics. But the most common bonds that we have interacted with, maybe at our high school, at college, are the ionic and covalent types of bonds. and we appreciated what they are. We see that ionic is when a metal and a non-metal combines together, or have the attraction, and they come together to form a compound that contains both the ionic and both a metal and a non-metal element of the periodic table. And then covalent is when we have our non-metals bonding to each other, having that attraction between themselves to form a covalent bond. Okay, so that is what bonding is. So we see that we have a knot. The bond may result from electrostatic force of attraction between opposite charged ions, as it is in ionic, and then sharing of electrons, as it is in covalent bonds. So in ionic, we also see that there is losing and gaining of electrons, whereas in covalent, the non-metals share their electrons. They share with each other. Okay, so that takes us to understanding what an orbital is. We see that an orbital is an electron wave function. It is a volume of space around the nucleus within which there is the highest probability of finding an electron having definite amount of energy. Atomic orbitals, therefore, describe the probability of finding an electron associated with a particular atom. The shape of an orbital is more important than its volume, and there are different properties that come about as a result of the size of the atom, and then that's why it is really important to know the shape and the size of the atom. However, we have different types of atoms. We have atomic orbitals as well as molecular orbitals. So when we look at atomic orbitals, we see that there are majorly 4 atomic orbitals that we need to know. We have the s orbital, we have the p orbital, we have the d orbital, and we have the f. And we always use this orbital to write or outline electronic configuration of an element of the periodic table. So when we look at the s orbital, the s orbital has ability to take in a maximum of 2 electrons, and then the p orbital takes a maximum of 6 electrons, d orbital takes a maximum of 10 electrons, and f takes a maximum of 14 electrons. So when we look at the periodic table, we find that it has different blocks. We have the S block, we have the P block, D block, and F block. And you look at my video I made on inorganic chemistry, introduction to inorganic chemistry, where we also looked at how we use these orbitals in writing electronic configuration. I hope you follow that video and understand more about what I'm talking about, how we use the orbitals, why it is necessary for us to know them, and briefly that. So we also have molecular orbitals, describe the probability of finding electrons within a molecule. And we have different types of molecular orbitals. We have the bonding molecular orbitals and then the non-bonding molecular orbitals. Bonding molecular orbitals have lower energy than atomic, and then non-molecular orbitals are associated with the molecule but do not take part in bonding. So that's on bonding. After we have looked at bonding, there is need for us to know what bond polarity is. But before we know what bond polarity is, there is need for us to know what we call electronegativity. What is electronegativity? Is the ability of an atom to attract electrons. We know that bonding is lasting attraction of electrons or atoms, ions in a molecule to form a compound or a chemical compound. However, electronegativity is the ability of an atom to attract electrons that it is sharing in a covalent bond. if electronegativity difference exists between the two bonded atoms and they are not large, the electrons are not shared equally, and a polar covalent bond, and vice versa. So we find that bond polarity is affected by electronegativity. When electronegativity is strong with the other atom, we find that it takes all the atoms, and when it takes all not atoms, electrons, it takes all the electrons or attracts all the electrons it has shared in a covalent bond, and then it takes it to itself. For example, if you and your friend have joined college and you decide to share your things or combine whatever things you brought from home together for you to use together, maybe sugar, for example, here we have sugar, and then maybe biscuits and the rest, so you combine and have them in the same box. And then when you're having an argument with your friend and you feel like getting back your things, you find that you ideally, like, if your friend is stronger than you, either in words, in fight, in anything, you find that you ideally get nothing from your friend. She takes whatever was combined and bees with it. But if you are the stronger one, you find that you are able to get everything, plus even what she had also contributed in the sharing. So that is what electronegativity. And when we find that thing, we see that you are stronger. And for atoms, we say that they are polar. They are polar and polar than the others because they are able to attract electrons that they are sharing in a covalent bond. Okay, so that is it on bond polarity. And after knowing bond polarity, this takes us to bond formation and bond breaking. Bond formation: how do bonds form? When they attract, they come together and form a compound, a chemical compound. And after they have formed a chemical compound, how do they break to also split and have their own structures and their ions? So another word for bond breaking, we can call it fission. Fission with FISSION. This is the breaking of heavier nucleus forming smaller nucleus, or is the cleavage of the covalent bond shared by atoms in a compound. Fusion: this is the combining of small nuclei to form large or heavier nucleus. That is fusion. However, we have types of fission. We have different types of bond breaking. You see, we have homolytic fission. The bond is broken symmetrically with each atom retaining one electron, resulting to unpaired electrons called the free radicals. So here we see that the chemical compound that was formed as a result of a covalent bond, we find that everyone, when they are splitting, they are able to take their things. Everything is divided equally. I still go back to the example I gave. If you and your friend combine your things together, you have formed a chemical compound, and then a time for splitting, you divide whatever is left equally. If it is 2 kilos of sugar, everybody takes 1. If it is maybe 2 boxes of biscuit, everybody takes. Even though it is 1 box of biscuit, you count it and everybody takes equal portions of what everybody contributed in the thing. For example, even in partnership, when you're doing partnership business and the rest, you find that people have shares and different percentage. So we see that everyone has to take equal shares, for depending on how it is stated and how it runs, how a partnership is running. So we see that homolytic fission, we are breaking the bonds symmetrically, equally. Another word for symmetrically, we are breaking the bond equally, resulting to everyone taking. And if everybody takes, meaning there is no more electronegative atom or element compared to the other. And that takes us back to what I was saying about electronegativity. The one which takes all the electrons shared is more electronegative than the other and more polar than the other. So here we find that they have equal electronegativity in themselves. Heterolytic type of fission, the bond is broken asymmetrically, leading to two ions. That is to say, either an ion with a positive charge on the carbon atom called cation, or to the ion with a negative charge that will give us an ion. So we find that here it is not shared equally because one of them is stronger than the other, or it is heavier than the other, more polar than the other, more electronegative than the other, where we say that electronegativity is able to pull all the electrons they have shared, that they had together, and it pulls to it itself. That is homolytic type of fission. I hope we are still in the same page and still moving together. Okay. So that takes us to functional group. Is another thing. We say that our carbons can have different functional groups. What is a functional group? Is a specific group of atoms within a molecule that is responsible for the characteristic of that atom or that molecule. Specific atoms in a molecule within a molecule that is responsible for the characteristics. And then we have different categories. We have a group that has hydrocarbons. So we see here we have a chemical class or a group, functional group, and then we see here the formula. This is the general formula, how they can be represented. And then when we are naming them, we use a suffix of ane. And here we are given examples and a few properties. So we see that we have alkane. Alkane is when we have carbon to carbon single bond, carbon bonds to carbon. Another catenation. Catenation happens where carbon is bonding to itself with a single bond. So these ones called alkanes can be represented by CnH2n plus, to general formula for all the alkanes, where N represents any number starting from 1. 1, 2, 3, 4, 5, and up to infinity. So the suffix, when we are naming them, we give ane. And then example of ethane. Ethane, we see that these are 2 carbon atoms. Meth is 1 carbon atom. Eth 2, prop, but, pent. In order, a pentagon has 5 5-sided is a 5-sided polygon. So if it is a 5-sided polygon, we see that a 5-sided polygon is pent. So we pentagon. We remove the gon, that is AGON, and then for us we put ANE, pentane. Properties: nonpolar, unsaturated, and then we have alkenes. Alkenes have this general formula having the suffix this, and then this also we see that these are 2 carbon atoms and they are unsaturated. And then we have alkynes. Alkynes have this formula, and then we have a suffix that we shall use, ethylene, ethylene or ethine. We can call it like that, and they are unsaturated. So that is one class of a functional group. We have those that have oxygen atom in them. That takes us to alcohols. Alcohols have this formula. We have ROH and then a suffix of OL. Examples: ethanol, aldehydes. These are carbonyl compounds. where we have carbon to oxygen double bond. We shall look at them more, but here we just needed to know the different functional groups. We have aldehydes, example, we have ethanol, and then ketones, we have this structure, and then we have a suffix of one on, and then example of butanone, and then we have carboxylic acids having this, and then oic acid. So we see that here we have added ethanoic acid from ethane or from alkanes, and then ether we have ROR, and then we have alkyl ether. So we can call this ethoxyethane. When we reach on ethers, we are going to see how these names come about. As for now, we need to know that. And then we have a group containing halogens. Halogens are group 7 elements of the periodic table. All group 7 elements of the periodic table are called halogens, where we start from fluorine, chlorine, bromine, iodine, and then we have astatine. Those are elements of group 7 of the periodic table. So if we have these elements bonding with carbon atoms, carbon hydrogen atoms, we say that these are haloalkanes, or we say they are haloalkanes, or we shall say they have their halogen compounds. So we see that haloalkanes are all these that we have listed, where they have carbon and hydrogen plus a halogen component in them. So we see something like this. We have Rx, R representing a number of carbon atoms and hydrogen that are not stated. And then the suffix we shall use alkyl halide, and then we shall have here ethyl chloride. Fluoroalkanes is an example of a haloalkane, where we shall have RF because fluorine has F. So we shall say alkyl fluoride, and then alkyl methyl fluoride example. Chloroalkanes RCl, alkyl chlorides methyl chloride. Bromoalkanes RBr, alkyl bromide methyl bromide. Iodoalkanes RI, alkyl halides methyl iodide. So those are different functional groups that we are going to interact with as we go on. So after knowing functional group, we need to know what a homologous series is. It's a group of chemicals which have similar chemical properties and can be represented by the general formula. Is a series of carbon compounds that have different number of carbon atoms but contain the same functional group. That's why we needed to know functional group first before coming to homologous series. For example, methane, ethane, propane, butane, etc. are all part of the alkane homologous series. The general formula of this series is CnH2n plus 2. Okay, so let's see how an example for homologous series can look like. For alkanes, we have CnH2n plus 2. So we see methane. If n is equals to 1, we shall have CH2 plus 2, which is 4, and gives us methane. Ethane is when we have n is equals to 2. When you substitute to this formula, n is equals to 2, we get ethane. When we substitute for n, we are substituting for this n. When you substitute for n is equals to 3, we get propane. When you substitute for n is equals to 4, we get butane. Alkenes have this general formula where they have carbon to carbon double bond. Carbon and carbon is bonding with a double bond. So when we substitute for n is equals to 2, we get ethene. When we substitute for n is equals to 3, this should be E. Okay, ethene, propene, and then we have butene for n is equals to 4 for alkenes. Alcohols, we have this general formula for alcohols and then we also substitute for N, and then its functional group is OH. Methanol, N is equals to 1, ethanol, N is equals to 2, propanol, N is equals to, we are talking about this N, you substitute in the formula and see its structural formula. We are going to look at the different structural and molecular formulas. That is why we are not substituting them now. Okay. Okay, so that comes to the end of our session today. We are going to look at up next nomenclature. How do we name organic compounds, and then look at also other things. Maybe start by looking at each functional group at a time, its physical and chemical properties, and then if they have official preparations, we are also going to look at them. I thank you so much for listening to me. Stay tuned to Graham Academy and keep tuned as we keep on understanding and doing something great.